So we're just doing this one, this year we're just doing this one intro video, or intro lesson, sorry, for just some work with algebra. So in this one we're doing expanding and simplifying, and we're going to do some solving equations. And I'll zoom in. Who remembers expanding and simplifying? That's okay. That's why we're doing this. Okay. So when expanding basically means multiplying. So I take this 2 that's out front, and a 2 beside a bracket means multiply. And it's called distributive property, and you multiply by everything inside the bracket. Okay. And then you stop because the bracket says stop. It says 2 of this, not 2 of everything, just 2 of that. So I stop. So this is 6x minus 14. Then I look at, what's this? I know it's a minus sign, but what does it mean? Jay? Negative. Negative? And negative what? Is negative something? There's a bit more to it. Yeah, very good. So it's going to, the sign is going to apply to the stuff in the bracket. Because it's kind of like a -1. It's not kind of like a -1. It is a -1. But so you could think of it as you're subtracting the brackets, or you could think of it as you're distributing a -1 through the brackets. Whatever way you like to think about it better. Or you just remember that that's what you do. And so you end up with -2x minus 5. Folks, what would be a really common mistake for this is they would do that. So the negative applies to the 2x, but doesn't apply to the 5. Because people think, well, it's in front of the 2x. It's not in front of the 5. But this is distributive property. So like that's what those arc lines mean, is that it's got to go to both. So it should be -5. Simplifying means collecting like terms. So now what I want to do, and normally I would not take an extra step to do this. You don't have to. But when we're just seeing it for the first time, it's a good idea, right? So I take the x terms. They are like terms. Why are they like terms? Because they have the exact same variable part. Okay? Exact same variable part. They're both just x. If one was x squared, that would be different. And I put the numbers together. They're called constants. I'll put them together. Then I actually add them. How do you add terms? 6x is like 6 x's or 6 apples. That's kind of what it means. 2 x's is like 2 x's or 2 apples. 6 apples, you take away 2 apples, how many do you have left? 4 apples. So 6x minus 2x is 4x. I didn't change the variable. I didn't do anything like that. Right? When you're adding and subtracting, you're just adding up the x's. And -14 minus 5 is just -19. Use your calculator. Get yourself a good calculator that you are familiar with. Mine's going to pop up here any second. Okay. -14 minus 5. If you're good at mental math and you can do that in your head, that's fantastic. Saves you some time. If not, then just get used to using your calculator and getting the answer. All right. And that one's done. You can't cram those together any further because they're not like terms. You can't add x's with constants. Where's my next example? Oh, it's down here. This is a nice course, in particular if the last course you took was grade 10 academic, because you could either have been in academic or applied and take this course. But if you're in academic, a lot of what we've done you will have already seen. We do some new stuff, but there's a fair bit of review from grade 10 academic as well. But you're seeing it for the second time. And you're a year older, so it's going to probably make more sense than it did before. Okay? That being said, there's still some challenging stuff in this course. And there's an expectation that you're able to really start doing this math that used to be hard in grade 9, but now we have to actually be able to do it. There's no more excuses. Okay, so keep that in mind. Some of the mistakes that we made in grade 9 and grade 10, we got to fix those now. Okay? But I've had a lot of people take this course and say that they feel a lot better this year than they did last year because they struggled in grade 10 and then all of a sudden in this course they start to feel like they're getting it again. That's a really good thing. Okay, so we do the same thing. I've got two brackets. The 4x gets multiplied by the first bracket because it's just in front of the first bracket, and the negative 5 gets multiplied by the second bracket because that's what's in front of the second bracket. So 4x is going to be multiplied by all three of those things. But here's the trick. What happens when I multiply 4x by 3x?
Because you have two x's, it's going to become 12x squared.
Very good. So you do the 3 times 4 as normal, 12. But when you multiply x times x, that's x squared. X squared. But look, when I add x and x, it is not x squared. And that's a grade 9 mistake. It's a big deal in grade 9. I don't know if you remember that in grade 9, but we make a big deal out of it. And like, they're different things. X plus x or x times x. And if you start putting the exponent in the wrong place, this is what I'm talking about. It's going to be a world of trouble. Okay, because it's going to cause everything to be a mistake all the time. Okay, now I'm doing the 4x times negative 7y. So again, I just do the 4 times negative 7, so that's negative 28. And x times y is just, yeah, good, just xy. Because xy means x times y. And 28xy means 28 times x times y. And hopefully we know that because if now we had to substitute in for x and y, like if x was 2 and y was 3, it would be 28 times 2 times 3. That's what that means. Okay, finally, 4x times 4y squared. So again, 4 times 4 is 16. X times y squared is just xy squared. They just keep the exponents that they have, and you write them side by side. This was the other thing I was going to say. Some people feel better about this course maybe because they think I'm going a little bit more slowly. Now that may not actually be true. It might just be that it's the second time around you're seeing it, and so you can pick up on it more quickly. So you think I'm going more slowly than they did in grade 10, but that's not actually the case. Or sometimes it might actually be the case that we go a bit more slowly. And some of you might get frustrated by that, like, all right, we get it, we get it, we get it. And it's really funny because if the teacher goes too fast, people are like, whoa, slow down. And then you go too slow and you're like, come on, let's speed up. It's like, what do you want from us? What do you want us to do? It's the same thing, same joke I make about if the math is too hard, people get really frustrated it's too hard. But then if it's too easy, they're like, this is too easy. It's like, oh my gosh, what do you want it to be? So be happy if it feels like it's moving a bit slow, even if you think it's a bit boring. Or if you think this is too easy and you just get it. That's a good thing, right? I think. All right, let's move on. So now the negative 5 is getting multiplied through, and I got to watch that negative. Okay? So negative 5 times 4x should be negative 20x squared. Negative 5 times negative 3, 2 negatives makes a positive. So that should be 15xy. Negative 5 times 11, probably multiplying by 11 is an easy one to do in your head. But again, if you struggle with that, then use your calculator. It should be 55. And then the 5 doesn't have any variable. So I'm just keeping the variable part from the brackets in every one of those cases. What do you notice about this? Anybody notice how this worked out? Because there's something that jumped out at me as I was doing this. What's our next step going to be?
Simplify.
Right. Can we simplify?
Yeah.
Why? Good. Yeah. So that's what I noticed is it worked out such that there's exactly 2x squareds, there's exactly 2xy terms, and there's exactly 2xy squared terms, almost like it was set up that way, right? It worked out perfectly. I just happened to notice that because when I multiplied the 4x by the 7y, I got an xy. And this one already had an xy, and the 5 didn't have a variable, right? So it just worked out that they're all exactly the same. So I have to put like terms with like terms, and at 12x squared minus 20x squared is 12 minus 20, which is negative 8x squared. Sometimes people think this squared applies to the number. And they think 12x squared is 144x or something like that. No, right? Definitely not. The exponent has nothing to do with the coefficient. If I did this, 12x all squared, now that exponent is on the 12 as well. But that's not the same thing as 12x squared like that. Okay, watch, that's a common mistake. Negative 28 plus 15. That looks to me like negative 13xy. And 16 minus 55, I think that should be negative 39. Did anybody already do that? Is that right? Anybody check that answer? No, you're just following me? Sometimes people like to try to go ahead. I didn't know if anybody already had it done. Any questions? So that's expanding and simplifying. Okay. The first question that we did, sorry, I'm going to go back up, just had a number out front, just the 2, and just the negative. So to show us what to do in each of those cases, because when you have just a negative, sometimes that can be something that trips people up. And then this one had the x out front, which was different, so we saw what to do in that case. And that's really all the kind of cases we're going to see. We won't see much more than that. Okay? So now we're going to do a little bit of solving equations, solve a couple of these, then we'll be done. Have a bit of a break to do some practice. So solving an equation is different from just manipulating an expression. Those other ones weren't equations because there was no equal sign in the middle. This is an equation to solve because of the equal sign. What does it mean to solve an equation? Lots of different ways you can think about this. And that can be a hard question. You might know how to solve it, but it might be hard for you to say, what does it mean to solve it? That's like a teacher's job, to explain things with words that way. Does anybody want to take a crack at that? What does it mean to solve an equation? Jay?
Maybe so the left side and the right side equal the same.
Good. I like it. Yep. What else? We could think of it in a different way, or we could build on what Jay started with. Yep. So just visually, what does the answer look like? It's going to look like R equals something. That's what you mean, right? In this case, it's an R. So we're getting that's great. 2 great answers. All the letters on the left, I almost always put the letters to the left and numbers to the right because it's just a good habit. You don't have to. In some cases, it might be a little bit faster to do it the other way. But if you sometimes have a hard time understanding why we do what we do, then it's good to come up with rules and just get in a habit. So always put the letters to the left. Okay? So we're going to isolate R. We're going to get R all by itself on the left side equal to a number. And what that's doing is that's finding the value of the variable that makes the equation balanced. So the left side and the right side are equal, and we need to find what R value keeps it true. So that's what we're doing. That's our goal. What's our first step? How do we do it? Any ideas? By solve each side, I'm guessing you mean expand each side, right? So, yep, good idea. We're going to expand the brackets first because they're kind of messing things up. So 3 times 4r is 12r. 3 times negative 3 is negative 9. Then I've got plus 3. Then I've got 6r minus 18. Now, there's 2 ways you can do this next step. I'm going to do it in 2 steps, and then I'm going to show you how you could do it in 1 step. Skipping steps or writing fewer steps is fine as long as you're getting the answers correct. You start making mistakes, go back and show more work. Because often what happens is, especially if they're little mistakes like negatives or you just added wrong, it's because you're trying to do too much at once. So you're trying to keep too much in your brain all at once. Okay? So go back to showing more work. That's the best way that you can avoid little mistakes. So what I like to do, my guaranteed method of success is whenever I have like terms on one side, I add them together. Okay? And sometimes you're going to have a whole bunch of terms on both sides, and it's really useful to simplify, and you're probably going to end up with something like this. An r and a constant on the left, and an r and a constant on the right, or x or a or whatever the variable is. Okay? And so you get this big thing that's got like 10 terms, and you pull it back down to 4. It just makes it easier. That's why we call it simplifying, because it made it more simple. Now what do I do? We said we wanted all the r's on the left. Are all the r's on the left? No. We want all the numbers on the right. Are they all on the right? No. So how do we move things?
You're going to want to isolate all the r's to the left.
Yep.
And when you cross over the equal sign, if you have to change the sign.
Very good. If you're adding or subtracting at least. If you're multiplying, dividing, it's different obviously. And the way I like to show this is above the 6r, I like to do a minus 6r. And whatever I do to one side, I do the same to the other. That's why it changes signs when it goes across. Because I have to subtract 6r, so it goes away, and I no longer have 6r on the right. But if I have a scale that's balanced, and I take 6 things off one side, okay, it's going to tip. So I have to take 6 things off the other side to keep it balanced. Right? You probably saw that back in elementary school. You've seen this for years, but sometimes that all of a sudden clicks for people. Okay, and then I'm doing the same thing here. I've got a negative 6. I want it to be 0. How do I make a negative 6 0? What'd you say? Positive 6. So in this case, I want to add 6. And whatever I do to one side, I do the same to the other side. And that's going to make this 0. And like when I teach this in grade 9, I tell the students, if you want, circle it and cross it out like that. Or maybe don't cross it out, but circle it and ask yourself, is the thing in the circle 0? Because if it's not, you've done it incorrectly. Sometimes if it's negative, people will still try to subtract. They'll go minus 6. Because I want to get rid of that 6, so I'm going to go minus 6. But negative 6 and negative 6 is negative 12. It's not 0. So they have to have opposite signs. So that can be a little trick to force yourself to double check that you have eliminated it. Okay? By circling it, just with a pencil faintly or something like that. Now, normally I wouldn't write this out. I'm going to write it out for clarity for the lesson. This is what we have now. So I've got 12r minus 6r, but that's gone. And I've got negative 18 plus 6, but that's gone. 12r minus 6r is 6r. Negative 18 plus 6 is negative 12. Final step? By? Good. Negative 12 divided by 6 is negative 2. So, both of these steps, I don't need. So I could have done this in 3 steps. And here's how, if you can do this successfully, then it's fine. I can, in my head, add -6 and +3 and realize it's -6, and I could have gone -6, -6, and -6r, -6r. I could have done it there, because this, especially if they're side by side, I don't know that I have to add it up and write it down. I can add it up, and oh, I did it wrong though. I was thinking what the answer was instead of actually what opposite. If I add 6, I get rid of both of those, and then I add 6 to the other side as well. I could do it that way. Saves this second step of writing this out. Okay? So if you like that, go for it. But if you've got 12, 14 terms, it's risky. It's not a lot of work to just write it out. That's when you're going to make a mistake. If you've only got 2, go for it. Okay? And just reflect on how successful you are doing it the different ways. But remember, my guaranteed way for success is to simplify down to 2 terms on each side, especially when you have a whole bunch. Definitely, I would be skipping that step. Okay? Because I can just do 12r minus 6r is 6r, right? All right, one more. And for this one, I think we're going to do a check. Yep. Stop me if you have questions. If you think you can do this one's a lot like the last one. It's just a little bit longer because it's got an extra bracket. Otherwise, it's the same idea. So if you think you can do it, go ahead. If you're at home and you think you can do it, pause the video and give it a try. But unpause and check your answer every so often. And same thing, I'm going to let you get a head start. Those of you that are in the room. And then when I start doing it, you're going to look up and check to make sure you haven't made a mistake. Generally speaking, our first step, if we have brackets, is to get rid of the brackets by distributing, right? So hopefully you started with that. Well, this is a good thing. Okay, just stop what you're doing and look. This is a common mistake. Some people make that 5. I'm not going to get you to put your hand up if you did that, but if you did that, or if you didn't, just watch for a minute. I want you to stop and watch. This is an easy thing to do, and even if you didn't do it now, you might do it on a test. Why? Because who knows what 2 plus 3 is? Everybody knows what 2 plus 3 is, right? My 7-year-old daughter can do 2 plus 3. And your brain's like, 2 plus 3, I know the answer, it's 5. Without even thinking about it, that's what you're supposed to do. And people just, like, your brain forces you to do it because 2 plus 3 is so easy. And most of us, at least, because other languages do it differently, but in English, we read left to right. So you're reading that question left to right. And so you see 2 plus 3 and you want to answer it without even thinking. This happens subconsciously, folks. This is what I have gathered from my years of experience. Why is it wrong to do 2 plus 3 first? The 3 is attached to the brackets. There's more to it than just that, but you're right. BEDMAS. It's 3 times W, and BEDMAS tells us we multiply before we add. So I have to multiply the 3 through first before I can add that 2. So that's a BEDMAS mistake. Okay, and it's a really easy one to make. Okay, continue. Done? Done? Nice. So there's all kinds of different ways that I could continue here. I could add 26 on the left, and then I would have to add 26 on the right, because I can see that negative 12 and negative 14 is going to be negative 26, so I add 26, right, if I wanted to kind of speed up the process. I can notice that if there's a 3W on this side and there's a 3W on that side, I could just cross them out. Because if I subtract 3W from the right, I'm subtracting 3W from the left, and it's going to cancel out. So you can actually cancel things as long as they're on opposite sides of the equal sign. I wouldn't recommend doing that, but unless you're really good at this stuff. What I'm saying is the more math you do, the better math you get. You don't stick to the specific rules or habits of one system of doing things. You start to become efficient. And in certain cases, you do it one way, in other cases, you do it another way. You know what I mean? And you just get good at seeing those little tricks. But I'm going to do it the safe way. So I'm going to collect like terms. So 3W minus 2W is 1W minus 26. And I only have the 3W here. And 2 plus 12 is 14. Now I'm going to add 26 to both sides because they have to have opposite signs. And I'm going to subtract 3W from both sides. Okay. And W minus 3W is negative 2W. So that's what you would have got if you had canceled them in the first place. You'd get the same thing. And 14 and 26 is 40. What's my last step? So we're going to divide, but be careful. This is a place where people make mistakes. What are we going to divide by? Yeah. Negative 2. Very good. Some people would just divide by 2. But you got to divide by negative 2. Okay? Check your answer. Make sure you got it right. We're going to do a left side, right side check, and then I'm going to let you practice on your own. So, what did we find? We found W to be negative 20. This is how I like to do it. Check. Does W equal negative 20? So that equal sign with a question mark through it is my way of saying, is this true? Because our check is going to tell us if it's true or not. So I like to do it that way. You don't have to write that symbol, but that's how I like to do it. And remember, left side, right side check is we split the left side and right side up into their separate parts. So I got to zoom out a little bit here so I can see the question. And this is a formal process. So in this course, you're not going to do a lot of checks. But if you're asked to do a formal check, you have to do this, folks. So watch. I want to see the first line with the variables. I know it seems like a make-work project, but sometimes we do things formally and we just do it because that's how we do it. Just like in an English paper that's formal, you don't use the word I. And you use capital letters and punctuation. Do you think you could write an English paper and not use any capitals and your teacher would understand what you said? Of course. Capital letter doesn't really help for understanding. It's a formality. If I write somebody's name, I write it with a capital. But you could read the name without it. Math is the same. Sometimes we do things formally, and we do it just because that's how we do it. For some reason, people seem to accept that in English, and they don't so much in math. And people say like, oh, why do I have to do that? I don't want to do that. Anyway. So I'm going to have brackets and brackets here. So I'm going to use square brackets. You don't have to, but you have to make it look nice. So I changed the round brackets to square brackets so I could put the negative 20 inside a bracket. When you're substituting in, that can be a really good thing to do, is always put it in brackets. Once again, when you get really good at this stuff, you may know when you need it in brackets and when you don't. But until then, you could just use the rule of always putting something in brackets when you are substituting. So I'm going to do both sides, substitution, and then I'm going to solve them one at a time. That's what they should look like. What am I hoping to have happen here? I don't want you to answer that, but that's something to think about. You should be expecting how this turns out. Notice that I did not distribute. Sometimes people do the distributive property here. No, this is like a bed mass question. You're doing brackets first. Negative 24. Now I'm going to multiply. Then I'm going to add. 3 times 24, that's negative 72. Plus 26. Whoops, is that 46? Negative 46. Anybody do that yet? Is that right? Check that math and make sure I did that right. Yeah, it looks like it's going to be right. 3 times negative 16 is 48, so negative 48. 2 minus 48 is negative 46. What happened? Coincidence? What a coincidence. Mariam, what were you saying? They're equal. That's what we wanted to happen. That means we got the answer right. So we make a statement, left side equals right side. Therefore, W does indeed equal negative 20. I don't write the question mark that time because now I'm saying it's true. Before I was wondering if it was true. Now I know that it's true. Any questions?